The basic idea behind Talos is to employ a number of mobile robots to prevent intrusions. Recently, the multi-agent community has focused on the problem of finding effective patrolling strategies. Talos supports a user to design patrolling settings and to find the optimal patrolling strategies considering rational intruders. Talos provides 4 main functionalities. Let's see how they work. Setting, composition and editing. In order to make a new map, you have to follow 5 simple steps. The first one is to set the map topology. Cells could be free, white, cells traversable by the robot. Obstacle, black, cells not traversable by the robot. You can change the size of the map anytime. During this step you can also place the targets, cells with some value for both the players. The entry points, cells whereby the intruder can enter. In the absence of these points, all the cells are possible entry points. When you have finished to set the topology of the map, you can go on with the step 2, to set the intruder's options. In this step you can set the intruder strategy as strictly competitive. The player's preferences over the target are opposite. Not strictly competitive. The player's preferences can be any. During this step you can also set the capture value, the value that intruder gets when it is captured. In the step 3 you have to set some values for each target. The penetration time, the time needed by the intruder to successfully strike a target. The patroller value, the evaluation of the patroller over the target. The intruder value, the evaluation of the intruder over the target. When you have finished to set all the values for each target, you can go ahead to step 4. In this step you have to set the range of the sensor. The robot can sense the current cell, some neighboring cells with a given probability. In the last step you simply have to select a name for your map and submit it to get back results. Optimal strategy computation. Once a setting has been completed, it is possible to find the optimal patrolling strategy. Talos provides 3 different resolutions with different degree of approximation to allow a user to solve even large instances. These resolutions are based on different degrees of abstraction of the setting representation. The result is a randomized strategy represented as a probability distribution over the next cell to visit. Strategy evaluation and comparison. Through the map manager you can manage all your previously saved maps. All the patrolling settings with the same topology are grouped together. A subtree view is used to group patrolling settings with the same parameters. Now we select a saved patrolling setting. See the parameters of the patrolling setting. Display the strategy by clicking the icon. Cyan background indicates the cells covered by the strategy. Cells with a light cyan are not present in the current abstraction of the patrolling setting. Red intensity on arrows is proportional to the corresponding movement probability. Probability values can be displayed when the cursor is moved over the corresponding arrow. In the table the expected utilities of the actions of the intruder are reported. In the columns we have targets, while in the rows we have the cells denoting the position of the patroller. We denote by blue color the best action per target, we denote by red color the best intruder's action. This table aids the user to find the weakness of the patrolling setting and then to edit the setting to make it more robust. It is also possible to compare strategies related to different variants of the same setting by a table reporting the expected utilities for each intruder's action. Other more detailed information can be downloaded from a log file. Interactive play. The generated optimal strategy assumes that the intruder is rational, but this can be unusual in practice where the intruder can be human. Talos allows one to evaluate a strategy when the intruder is human by interactive play. The user can repeatedly play against an optimal patroller by observing the patroller movements and deciding when to attack a target and what target to attack. Once the user has clicked on a target, the patroller moves for a number of turns equal to the penetration time of the targets according to its strategy. After a number of repetition of the game, a table provides the intruder's utility and compares it with respect to its optimal strategy and shows how much is the increment of utility for the patroller. The demo is over. Thank you for your attention.